Hi, my name is Rosemary Alden, and I'm an undergraduate research fellow. My project is forecasting of residential electric loads with a minimal data set from smart meters and intelligent circuit breakers. I work with Spark Laboratory, and with my research advisor is Dr. Dan Ionel. The basis of my project is that as penetration of distributed energy resources increases, electric generation and load forecasting is becoming increasingly important. Utilities will need to depend more on predicted generation and load forecasting to balance the grid each day. New methods for collecting data to support forecasting with the desired accuracy are needed. My proposed approach is to review the technologies providing residential data, pre-process said data, and implement machine learning techniques for analysis. Longer term, it is my goal to determine the minimal data set for desired accuracy of prediction. Advanced monitoring technologies such as intelligent circuit breakers and smart meters will be used in the future to provide residential data for electric load forecasting. They can provide aggregated and deaggregated load profiles for analysis. In this project, I will format available data to be in the form as if provided by these devices. This is at the minute, 5-minute, and 15-minute time step. The big data used in my project is from robotic houses provided by the Tennessee Valley Authority and publicly available Honda Smart Home. I'm using an Energy Plus model of the TVA home I created and the programming language R to pre-process the data to the desired sampling resolutions. The categories I have predicted will carry the most influence on the residential load forecast and are included in a minimal data set are the HVAC and water heater dedicated circuits as well as the electric mains. Advanced neural networks and long short-term memory networks are machine learning models used for electric load forecasting. Advanced neural networks predict based off of trends and the patterns in the data, whereas the long short-term memory networks include the previous state of the output to increase accuracy. I will use the TVA and Honda Smart Home formatted data in the categories of interest as the training set for machine learning network to produce an electric load forecast of a specified period of time, most likely a single day. I have provided in the upper right of this slide the TVA HVAC consumption and the hourly and minutely sampling resolutions, as an example of the input data to the network. The two figures on this slide at the bottom show a single neuron in the network and then the configuration neurons in an advanced neural network provided from a recent publication cited on this slide. The nature of residential loads is much more volatile than industrial or commercial loads due to a number of factors, such as individual human behavior, variable load patterns that result from weekday, weekend, and holiday schedules, and other seemingly random influences. For example, HVAC consumption makes up a considerable portion of home consumption per day, but is not consistent day to day. The top of this slide is a color map showcasing the variability of the Honda Smart Home's HVAC power consumption over the winter. The bottom graph shows a single day with 3 different sampling resolutions, mimicking the data provided by a smart meter or intelligent circuit breaker. The difference in load profiles between the 3 resolutions is large and is a key focus of my project. I will use long short-term memory analysis for the minutely data because it performs better with a small amount of time between points and an advanced neural network for the quarterly and hourly resolutions. A special thanks to my research advisor, Dr. Ionel, and other acknowledgments are made on this slide. Also included are publications and reports since May.